All right, hello, folks. Today we're going to be going through the scale of the universe. It's a really fun thing to talk about to get a baseline for how gigantic, how enormous all this stuff is. We're really we're going to start out talking about stuff that's kind of closer to us, and then get further and further away, just to understand that those stars that you see up in the sky uh, are ridiculously far away. It's taken them many years for that light to get to us just because of how far away they are. The page that I'm getting most of this stuff from is the big picture part of general astronomy. You can read through it if you want, but I'm going to be going through it here step by step for the most part. Now, when we're talking about the scale of the universe, we have to use a really big measurement unit because we're talking about a gigantic distance, right? If I were to ask you, for example, like how far is it from here to Las Vegas? You wouldn't measure that distance in centimeters, right? So, in the same vein, if I am talking about from here to the next galaxy outside of the Milky Way, we're not going to use miles to represent that because it would be hundreds of billions of miles of distance, a huge amount of distance. So we have a different measuring system, which we're going to talk about here today. To start out, though, I want to talk about the close stuff. So our next closest thing off of planet Earth, of course, it's our good friend the Moon. Whoa, there he is. It's everybody's favorite moon. It orbits around planet Earth, and you can see it every night. It goes through different phases depending on how the sun's light is hitting it. It's pretty far away from us. Here I've got a good little representation that shows to scale, it is to scale, the size difference between Earth and Moon, and also the distance difference between Earth and Moon. Here's us, and there's the Moon. Now, why is this so large? Okay, let's do some drawings. To get from Earth to Moon in a rocket ship, it would take you. Uh oh. Uh oh. Uh oh. Uh oh. Clear. All right. Take two. Ready? Be warned. I'm drawing this with a mouse, so it's going to be not good. All right. If you were in a rocket ship and you blasted off from planet Earth and flew up to the moon, it would take you 3 days of travel, roughly, because that's how far away the Earth is from the moon. Now, obviously, we haven't sent a rocket to other galaxies or other stars outside of our solar system. They're really far. The moon is the closest thing to us, and it would take you 3 consecutive full days of travel in order to get there in a rocket ship. So, when we're measuring distances in space, we have to use something a lot faster than a rocket ship. So, we use light. Light is the fastest thing there is, period. Um, it moves so much faster than any man-made vessel has ever traveled. It's orders of magnitude way faster. And to give you a good example, distance from Earth to Moon, rocket ship, it would take 3 days of travel. If I were standing here on planet Earth and I had like a laser pointer and I pointed it up to the moon, click, and shot that beam of light up to the moon, and it went bing, it would take light a little over 1 second to get there. 1.2 seconds, if I recall correctly. There we go. Just to give you a rough indication of how much faster light is than a rocket, one of the fastest things we've ever created, right? 3 days for a rocket to get to the moon, 1 second for light to get to the moon. Incredibly fast. So, we use light's movement to measure how far away stuff is out in outer space. We would say that the distance from Earth to Moon is. Erase all this stuff. Because of this, the distance from the Earth to the Moon, we would say that it is a distance of 1.2 Oh boy, here we go. Light seconds. No, my face is in the way. Light seconds away. That's a distance, like miles or kilometers or meters. The distance from the Earth to the moon is 1.2 light seconds because it takes light 1.2 seconds to travel that distance. Hopefully that makes sense. So let's get a little bit further away. Uh, Something a little bit bigger, something a little bit further away. Bam! The sun. It's our good friend, the sun. He's always up there providing heat and light and warmth and life. Thank you, sun. The sun is further away from Earth than the moon is. It takes that same light. If I were standing here on planet Earth and shot that laser pointer up to the sun, it would take that light right around 8 minutes. Boop, to travel from here to the sun. The sun is very, very far away. Ooh, how many miles? 93 million miles? I don't know where I'm getting that number from. Distance to sun in miles. I was pretty close. It's 94 million miles. So it would take light 8 minutes to travel 94 million miles. Oh, the mouse is no good, folks. It's no good at all. Million miles. So it would take that light 8 minutes to travel 94 million miles. Incredibly, incredibly fast. But it gets bigger. That's just stuff inside of our solar system. 8 minutes of travel to get to the sun. Obviously, there's stuff if we go away from the sun that's further, but we want to get out of our solar system. Let's talk about the next closest star. Beyond the sun, the next closest star is called, I can get rid of all this stuff. It's called Proxima Centauri. Do I have any good pictures of it? Let's see. Boop. Proxima. Oh, there we go. Perfect. Proxima Centauri. I'm so zoomed in. All right. This is a picture taken by the Hubble Space Telescope, which we'll talk about in the future. It's outside of our solar system, if you don't know already. The sun is a star. This is just like the sun, just further away. So when we look up into the night sky, there is a star up there. This is the next closest star to us. It's called Proxima Centauri. Proxima Centauri. Excuse me. So light can get to the sun in 8 minutes. We would say that the distance to the sun, remember we said the distance to the moon was 1.2 light seconds because it takes light 1.2 seconds to get there. The distance to the sun would be 8 light minutes because it takes light 8 minutes to get there. Now imagine for your second, if it can get to the moon in 1 second, it can get to the sun in 8 minutes. Think of how much distance light could travel in a span of a year. If it was traveling in a straight line for 1 whole year straight, the entire time, we would call the distance that it traveled in 1 year a light year. And maybe you've heard that term before. It's a measurement of distance, like a mile or a kilometer. That distance that light travels in 1 year, we would say that length is 1 light year. And we use light years to measure vast distances in outer space. So Proxima Centauri, this guy here, it is a little over 4 light years away from us, meaning it would take light, the fastest thing there is, a little bit more than 4 consecutive years of travel to get from planet Earth to the next closest star. Extremely far away. Super, super far away. That's Proxima Centauri. Bigger. All right. This is an artist's representation of what the Milky Way galaxy might look like. If you don't know, we're in the Milky Way galaxy. Our solar system is somewhere out on one of these rings out here like this. I'm not sure where exactly, but one of them. The Milky Way is made up of millions of stars, tons of stars. Proxima Centauri is in there somewhere. Our sun is in there somewhere. All the constellations you've seen up in the night sky, every star that you see with your naked eye is in the Milky Way galaxy. Obviously, this is not an actual photo of the Milky Way galaxy because we're in the Milky Way galaxy. Uh, we can't get a good picture of it because we've never been outside of it. It would be like trying to get a picture of the front of your house from inside your kitchen. Kind of tough. But we've seen galaxies outside of our galaxy. We've seen the house across the street. So we can kind of estimate what our galaxy probably looks like. The Milky Way galaxy, the distance across it like this. Whoop. If I were standing right here and I pointed that laser pointer across the galaxy and fired it off, I would come up with a distance of 100,000 light years. Meaning, I click that laser pointer, it would take that light, that fastest moving thing there is, 100,000 years to travel from one end of the galaxy to the other. Which is the reason why we haven't left, because we would all be long dead before we ever got out. A massive, massive, massive amount of space. Huge distance, 100,000 light years across. An absolutely gigantic galaxy. Huge, massive. You know what? I'll stop there. And then the next video, we can look at some incredibly fascinating images of some other galaxies outside of our own. Cool. Hopefully you got a good understanding of what a light year is. If not, feel free to ask questions. Go read through this page if you're still having questions about it. It's covering all the exact same stuff that I'm talking about here, but if you're interested and begging for more, that's where it is. All right, see you in the next one. Bye.